Welcome to module D, lecture 8. In this lecture, we shall discuss about doubly constrained gravity model. In lecture 7, we discussed in details about the calibration of friction factors using BPR method. I would like to remind you once again what we did in the calibration procedure. Basically, we tried to match the trip length frequency distributions as observed from the field and as obtained from the gravity model. So, in gravity model, before we actually calculated the TIJ values, the trip interchange values using gravity model, we assumed some values of Fij with respect to different travel times, and then using those Fij's we calculated the trip distribution, and then what we did 5 minute how many total trips, 10 minute how many total trips, 15 minute how many total trips, like that we calculated. Then we express this total trip into percentage of the total trips made, right. So, then how much percentage of total trip is made for 5 minute travel, how much percentage of total trip is made using 10 minute travel, how much percentage is made using 15 minute travel, something like this for different travel time or the different trip lengths. These are the frequencies obtained from gravity model, and we also matched this with the frequencies as we observed from the field data, and we tried to match them closely by going through several iterations and modifying the assumed Fij value based on the kind of mismatch, whether the gravity model is predicting higher or the observed values are higher, okay, with respect to that travel time, right. And then finally, what it gave us? It gave us the way the travel time is acting as a deterrence is captured nicely by these Fij values, and we find the percentage of trips made with different trip lengths or different travel time is actually getting captured nicely by these Fij values in a singly constrained gravity model, and the values are close to what it is observed in the field or observed values in the field. So, that is the match, gross level match, but as I said, the total 5 minute travel are matching. So, that time how it is acting as a deterrence is grossly it is matching, but then if total 10 minute travel is matching and if travel time is the only factor influencing this trip distribution, then the multiple cells which have the same travel time, right, those cells values automatically should match, because my overall gross percentages are or frequencies are matching, right. So, if travel time is the only factor, then individual cells automatically match, but then we may find that although the total 5 minute or total 10 minute or total 20 minute travel, the percentage of total trips with that travel time is matching, but then that might be total travel 10 minute travel might be coming from 3 or 4 different cells. Now, this 3-4 different cells, the total is matching with the observed one, but cell to cell still not matching. That means, there is something beyond the travel time or beyond this friction factor. Okay? That is basically the composition of people, the socioeconomic distribution of people in different zone is different. So, some additional adjustment factor we used, what we told is as zone to zone adjustment factor to match these even individual cells in a reasonable manner. That is what is the role of socioeconomic adjustment factor. Now, with that, today we shall discuss about doubly constrained model, and as I said earlier, what is doubly constrained model? The both ends should match automatically, based on the model formulation. Like the way I am writing the Tij equal to something, if I sum it over j, I should get Pi. If I sum it over I should get Aj. Then both ends are matching automatically by the model itself. Model itself will ensure both ends are matching. Singly constrained, only one end was matching, the other end was not matching. We had to do something externally, right. But here no need to do something externally, the model form itself will ensure that. So, that is what I said. General form is alpha into pi aj fij, that is the general form. The above statements represent the flow conservation constraints and are given as follows. Normally, as I said, that two constraint means this one Tij sum over j equal to Pi, sum over Tij sum over I equal to Aj. Now, to ensure this, normally in a doubly constraint model, there are two balancing factors what we use. They are called Ki and Kj. So, what is the value of Ki? Ki equal to 1 by sum over Kj, Aj, Fij and sum over what? J. Similarly, Kj equal to 1 by sum over Ki, Pi, Fij, sum over I. You can clearly see this is something very interesting. The Kij value depends on Kj value, Kj value depends on Ki values. So, what it indicates? It indicates that you need to go for an iterative process, right, to get stable values of Ki and Kj. When we can say the values have stabilized or your stable values are stable, when from one iteration to another iteration the Kij and Kj, Ki and Kj values are really not changing significantly or the change is very negligible. So, that is what is a doubly constrained model. Here I am showing the classical version of a doubly constrained gravity model. Tij equal to Ki, Kj, as I said these two are balancing factor, Ki, Kj, Pi, Aj and Fij. What is Fij? Fij is the the friction factor, whatever you say, or we can call it a generalized function of travel cost, right. And how to get this Fij value? You can, so many ways it can come. One possible way is you can take it as a function of the Cij, the cost of travel, generalized cost of travel, that is one possibility. Now, how to do the calibration? Calibration we can do in steps. The very first step is we assume that all Kj values for all j, the Kj is 1 or unity, that is my starting point. Then go to step 2. For this assumed value of Kj as unity, now you calculate the value of Ki for every I. How we calculate? As I said, Ki equal to 1 by sum over Kj, Aj, Fij, sum it over all j. Now, obviously, Kj values are 1, but then with that one value of Kj, you can now calculate the value of Ki. So, you have now got a set of Ki values. Now, with this Ki in step 3, now you go back and calculate the value of Kj, iterative procedure. So, how you will go and calculate the value of Kj? Kj equal to 1 by sum over Ki, Pi, Fij, okay, and sum it over what? I. The Fij is the friction factor. As I told that sometimes you can use Fij, and here also I have said it Fij. is the friction factor or the generalized function. Okay. In so many ways, you can make it as a function of cost, you can make it as a function of time, right, but it is basically the friction factor values. Now, what we did? We first assumed Kj as 1 for all j, then with those Kj's we calculated all values of Ki, that means value of Ki for all I, then again with those sets of values of Ki, we went back and calculated value of Kj for all j, and after this we can even go back now and apply this model, doubly constant model, because we have a value set of value of Ki, we have got a set of value of Kj, then we can calculate Ki, Kj, Pi, Aj, Fij, and using this doubly constant model we can calculate the value of Tij. We can do that. You have known value of Ki for all I, you have known value of Kj all j, you have given value of Pi for all I, you have given value of Aj all j, and you also know the Fij values as I explained in the beginning of this lecture and also in the previous lecture, that how we can develop Fij values, right. So, similarly, you have also calculated the value of Fij. So, all are known, I can calculate Tij values. Then I can also calculate in step 5 what is my error. That means, for every I have actual production and I have an estimated production values from the model, like Tij sum over all j, I will get a Pi. So, what is the difference in the production for each zone? Similarly, what is the difference in the attraction in each zone? The absolute values we can take, because some may be positive, some may be negative. So, we need to take the absolute values, right. So, that gives me what is my total error, what is the total mismatch. Now, if this mismatch is not very significant and if you as a modeler you are happy, then you stop here, no problem. But in all possibilities, with this iteration, wherever you have reached till now, you will find that there are certain errors, maybe at the production end or in the attraction end. Okay. There will be errors, and these errors are probably you are still not happy. So, if that is so, you want to know I still should get a better match at both ends, right. Then what we have to do? We have to go for further iteration. Now, why this error has come? You have Fij value, does not change, time or cost is given, correspondingly somebody has calibrated the Fij values. So, you are not changing anyhow in the context specific case, given problem you are not changing the Fij value. So, Fij will not change, Pi will not change, Aj will not change, right, given Pi, given Aj will not change. So, what will change? What will influence these Tij values? It is only Ki and Kj, the balancing factors. So, balancing factor, that means still you have not got the correct values of the balancing factors. So, if there is an error here, that is coming actually because of this balancing factor Ki and Kj. So, you have to go back to that area. So, what we will do? We will again go back to step 2. That means, we have certain values of Kj, with that we will again calculate Ki. With that those values of Ki, we will again go to step 3, calculate again the values of Kj, right. And then you can again come back to step 4, do the trip distribution, and then you can again check what is your error value. If you are satisfied, fine, otherwise again go back, do one more iteration, and because finally our aim is that we want the production ends and the attraction ends to match as per our expectation or within the permissible error or within acceptable error rather, right. So, till we are satisfied, every time we come back and we calculate. If we are not satisfied, again we will go back, we will make one more round of iteration. We calculate the given the kj last set, whatever was my kj value, I will calculate ki value, and then with those ki revised ki value, I will again go and calculate kj value, and like that I will keep on iterating, and sometimes things will converge. This is one possible way you can do it. The other thing, as I told, what needs to be adjusted here is only ki and kj. The remaining thing, once you apply, see this doubly constraint model, I go back and show you ki, kj, pi, aj, fij. So, pi does not change, aj does not change, fij does not change. So, what changes? Only thing changes is ki and kj. So, it is all about balancing this or making this balancing factor stable. So, another possibility what you can do, I need not go for step 4 and step 5 again, probably I need not go back. I will start with step 1, starting kj as 1, then go to and calculate in step 2 ki values, then with that go to step 3, calculate the kj value. Again I will go back to step 2, with those calculate ki values, come back to step 3, calculate kj values. So, step 2 and step 3 I will keep on repeating. How long? Till the time I find that ki and kj values are not changing so much. That means, you can always keep an error or keep a limit of the change in the values. So, whatever you got the kj values in previous iteration, now in the new iteration your kj values are not so different from the previous iteration. So, you can always for every zone j, you can actually compare what I got in the previous iteration, k 1, k 2, k 3, k 4 for all the zones, what are my k values, and what I have got now, what is my difference. So, naturally, when the difference is not that much, that means your ki, kj values have stabilized. Even if you go for one more iteration or two more iteration, the values are not going to change significantly. Then with that you directly come to step 4 and directly come to then step 5 and check that whether your errors are within acceptable limit. And in all possibility, if you have really stabilized, the values are stable for ki and kj, the balancing factors, then you are expected to get a reasonable error or within acceptable limit of error in your step 5. So, step 4 and step 5 you can omit also and you straightway can iterate, or as I said earlier, come up to step 5. If you are not happy with the final result, go back to step 2, 2, 3, 4, 5, again you are not happy, go back to 2, 3, 4, 5, that is another way you can do. Both are possible. If you see different books and other materials, you will find both ways people have addressed this doubly constraint model. Now, let me take an example where I have said that I have only 3 zones, again a classroom example. The productions and attractions are given and you can see they are matching. The total productions from the study area is 2420, total attraction is also 2420. So, they are matching closely, there is no issue in that. And then in this case, instead of distance, suppose the friction factors have been calculated based on Cij value and it is assumed that friction factor is 1 by Cij. This is just an assumption, right. So, instead of giving separate friction factor, in this problem it is assumed that Fij is 1 by Cij. Although you know by this time how to calibrate Fij values, you can always calibrate it, right. but in this example instead of giving directly the Fij values for different corresponding cost or corresponding time, one can assume that Fij is 1 by Cij, which is again logical, because the cost will be higher, the multiplier will be less, Fij will be less, right. Cost is lesser, the Fij value will be higher. So, 1 by Cij is taken that way. So, with this we go for the first iteration. What we get? We get the value of as I said that this is the Fij matrix. If my costs are this, Cij values are this, then 1 by Cij is my friction factor values. So, I have got the Fij matrix. I got assume now Kj, all Kj equal to 1, and with that we want to calculate Ki. That is what I have shown here. You can see in step 2 what we have done. We have taken the Jones product I as 1, 2, 3 in 3 rows and J as 1, 2, 3, 3 columns, and then calculated this value Kj, Aj, Fij. Kj is assumed as 1, Aj we know the attraction of zone each column, that is 1, 2, 3, and then corresponding Fij value we want 1, 1, 1, 2, 1, 3, what is the cost value and then what is the corresponding Fij value, you put that, then sum over Kj, Aj, Fij, sum over all j, that means sum over all columns, and then we also calculate then what is the value of Ki equal to 1 by sum over Kj, Aj, Fij. So, whatever you have got in this sum over Kj, Aj, Fij, sum over all j, take 1 by that, you will get this value of Ki. Now, with this Ki value, now I go on the right side as I say in step 3, but the table I have shown it on the right. So, we can calculate now the value of Kj. How we do? Again I say my I and j, we put the value now Ki, Pi, Fij. So, my column wise I calculate the value, I calculate the column total, that is Ki, Pi, Fij sum over I. So, you have the total, and then you calculate the corresponding Kj is for that zone, each of these zone destination zones, right. What are the thing? 1 by sum over that, whatever is calculated is shown here, right. So, like that you can do step 2 and step 3. With that, now I apply this Tij, Ki, Kj, I have all values of Ki, I have all values of Kj, I have all values of Pi, I have all values of Aj. So, for all I equal to 1 to n, j equal to 1 to n, I know Ki, Kj, Pi, Aj and also the Fij values. So, simply apply it, I calculate the trip distribution matrix. Then I show how much I have got, okay, and what was my estimate, right. So, both are known. So, the Pi is 1250, attraction is 1230 for zone 1, 1250, 1230. Now, you got estimated is 1235 production instead of 1250, and attraction has matched, okay, because Aj values final we have used that. So, that is that will balance, right. So, that is a matching. So, now we are not still happy, because we find that we are calculating the error and we find that there is still an error and we are not happy. So, what we want to do now? We want to again go back, still there are errors. So, we are repeating step 2, 3, 4, 5 in this case. We are going back again calculating with that Kj value, what are the Ki values, with that Ki values, what is the Kj value, and then come back. That is what is shown here. So, here we are again going for iteration 2 and going back to step 2. So, with that last set of Kj whatever we got, now we are actually calculating Ki, and then the right side with those Ki values I have shown a table where we are calculating the Kj values, right. So, step 2 and 3 are repeated. Then we are again doing the matrix and now it is matching, right. So, it is a small example. So, it may match maybe with just 2 iteration, but you take any example, it may require more number of iteration and still there may be some error which are marginal and may be accepted for any such kind of planning exercise, right. So, this is the overall procedure how you apply it, right. Now, before we close this discussion, we have discussed about gravity model, what is gravity model, singly constrained, doubly constrained, BPR calibration technique, how to apply singly constrained model, how to do the balancing, how to apply the doubly constrained model. We have explained you here clearly, right, and with an example also we have shown you how you do it. Now, before we close, let us talk about some of the considerations, right. What are the real potentials or advantages of gravity model, and in some cases we need to be little bit careful. So, I do not want to say disadvantage, but maybe some of the considerations where we have to be careful, right. We should understand and bear those things in mind. Let us go to the advantages. So, it used a causal relationship. So, the first thing is it uses a causal relationship. That means, why some places more trips are going as compared to other places, or why to some places less number of trips are getting terminated as compared to other places. So, that logic is actually captured in terms of trip attraction and resistance. So, you can call it as pull, how much trip I will be attracted to a zone J, it will depends on what is the level of pull, that means what is the attraction, more the attraction more will be the pull. Similarly, what is the resistance, more the resistance less trips will finally get attracted to that zone. So, that causal logic is inbuilt. Second, it recognizes that the trip purpose affects the pattern which can be solved independently by different trip types at same time of day. So, the effect of trip cost or travel time is not same on all trip purposes. That can also be considered advantageously. What we all need to do? We need to calibrate separate Fij value for separate trip purposes, maybe work trip, work and business trip, one curve or one set of calibration, and some other trips a different calibration. So, this gives an opportunity for that, right. The same 15-minute, the way the increase or decrease in travel time or so, the way it will influence the work trip, exactly the same way it may not influence the education trip or educational trip, or exactly in the same way it will not impact the recreational trips, right. So, the impact of travel time or travel cost on friction factor may be different depending on the trip purpose, and one can calibrate it separately. Improvement in the transportation facilities can be improved. That is the greatest advantage of using this kind of gravity model. As a matter of fact, any kind of synthetic model, the transportation system is improved, the travel time is improved, the travel cost is improved. One can check with those. Now, a revised distribution will come because of inclusion of Fij, which is eventually again a function of cost or function of time or function of some characteristics of the transport network, and it includes intrazonal as well as interzonal trips. All diagonal elements are also estimated, and also the other elements which are interzonal elements, those are also estimated. But there are also some kind of general considerations. I do not like to say them as disadvantages, because it all depends whether you are applying it properly. If you apply it properly, then it may not be anything negative, but one has to understand and keep in mind. For example, the travel resistance may vary with trip purpose or even time of the day. The trip purpose we probably mentioned here, that it gives an opportunity. So, probably trip purpose, it does not sense much logic for me to include it here, but even the time of the day variation, right. But time of the day variation also, it may not be so easy, but if you wish, you can also develop several friction factors. So, I would not like to say it as a clear limitation, but one has to keep it in mind. If I want that different times things should be different, different purpose things will be different, right, or home based or non home based trip things will be different. If I want to consider their effect, I have to calibrate my friction factor. Yes, the limitation is you have to go, and disadvantage also you can say in that way, you have to go and calibrate it as per that. The way you want to apply, you have to then calibrate the friction factor separately. And if you do not calibrate it separately, then it may result overestimation or underestimation. So, the way you want to apply your thing, if you want to consider different times, peak and off peak differently or trip purpose differently, like shopping, education, work separately, or maybe home based and non home based trip separately. If you want to apply and if you want to distinguish between or among different trips, then you have to accordingly develop the friction factor value curves, because you are believing that the deterrence probably will be different. Yes, they may be different, but then you need to consider. So, if you do not consider and then try to account for that in your model, you will not be able to do that. Then another thing is that, remember, this is true for the gravity models, true for any other models we are doing. We should not do too much tuning of the model. The problem is these days with computer, you can match everything even probably with with high level of accuracy. Number to number, cell to cell I can match. Okay. But please do not do that. That is the advice, because if you are doing excessive fine tuning, you might be actually doing lot of distortion, and when you want to predict, you never know, because of too much, actually you might have done so much of distortion that you will incur much more error in prediction, right. So, remember that it is a planning, for planning purpose we are doing it. So, always there will be some error in model estimation, some error in the data collection, anything. I mean, the whole modeling work cannot go without error. All what we need to ensure that our error is not too much, right. So, that is why gross checking, gross level of matching, that we want. But as I said, even zone to zone adjustment factor or socioeconomic adjustment factor, beyond trip length frequency distribution, why the individual cells are not matching? Because of the socioeconomic composition. So, if you really use it too much to tune each and every cell value, you might be actually incurring some error, because in future there may be some minor changes in the socioeconomic distribution. And if there is an error and you have tuned it so much, then the error also will be so much. So, it is better sometimes, of course, gross matching, error within acceptable limit, these are all very important thing. I cannot work with a model where you have so much of very high 30% error, 25% error, probably it is not acceptable, but 5% error is fine. Let us not tune the cells too much. So, remember that tuning is good, but too much of tuning may be something wrong, because you are actually maybe distorting it too much, and you may incur actually higher level of error in your predictions. So, with this, so what we discussed in this class or lecture, we basically discussed the FIJ calibration related thing, what we are doing, and then the role for zone to zone adjustment factor, why we say zone to zone or socioeconomic adjustment factor, because this is something beyond the effect of the deterrence due to time or deterrence due to cost, something else, right, which is likely to be due to socioeconomic composition. Then we talked about doubly constrained model, we explained you clearly how you calibrate it and with an example, and then we also discussed about the various advantages of gravity model and some of the general considerations where you need to be little bit careful when you are applying the gravity model. So, with this I close this lecture. Thank you so much.